So I'm going to show you a quick example on how to go acquire control or acquire coordinates from like a primary control scan, but utilizing the RTC 360's internal sensors to keep that laser scan perfectly level. There are some pretty rare instances where if you're really far away from your control scan or having common overlap or the site conditions changed, sometimes as you tie into those primary control scans, it can throw your alignment out of whack slightly to the point that it could throw a data set out of level ever so slightly, enough to make it a cause for concern for some as-built requirements. So in this instance, I have a smaller data set, and also I have my primary control scan with the rest of these bundles. So obviously, as you can see, they're pretty far away, so this is where this kind of example would come into play. But before we get into any of that, there's a few things you have to do first. So with this bundle, at this point, I already have my registration dialed and done, and I'm happy, and it's exactly as I want it. And so since there's no control applied and there's no links tied back into the primary control scan or anything that has previous coordinates or setups, everything's just internal to the setups from my current project, my current data set. And as a result, it's going to be very, very accurate for how it maintains level throughout this project. As soon as you tie it into other data sets or other scanners or other coordinate systems, like a primary control scan, there's slight chances they could throw it out of level as it tries to best fit and match that primary control scan. So in this instance, step one is you first have to go find or scan in an existing benchmark or a known elevation somewhere. In this example, since I didn't have anything specific, I'm just going to kind of arbitrarily throw this virtual target out in the middle and call it my 100 elevation. So this is more or less the benchmark I'm using to set the final elevation of this data set to, but there's a couple more things you have to do. So after you have your kind of benchmark target created, before you tie into your primary control scan, you have to go and create 3 or 4 other virtual targets to go and use to record the XYZ values. So here I created one kind of in this northwest, one in the northeast, and then one more kind of in the southwest corner of this little data set. So now we have those created. We're going to go turn off our point cloud. And so once again, I know that this center benchmark is 100, or I'm calling it 100. So now you have to go and record from this benchmark to the other points this delta Z value. One, it'll let you calculate the correct elevations based off of your known benchmark. But two, and more importantly, since you're doing this before you tie it into that primary control scan, you know that it's not going to change or it's not going to go out of level. It's going to retain the exact levelness as it sits right now before we tie it into control. So I'm going to go bring in my text file just to go and record these values. So I know that my first point is top left. So always you want to start from your benchmark going to your other points. So I know that my delta Z is positive 1.56. So I'll just take my 100 plus, oops, go clear all this, 100 plus 1.586. So now that is my target 1 correct elevation. So 101.586. And same thing, benchmark to control point 2, delta Z of positive 1.033, 100 plus 1.033. So now my second point is 101.033. And lastly, my third point, we're going to go benchmark to my last one, so negative 1.337. 100 minus 1.337. So now my last point is 98.663. So those are my corrected elevations off a benchmark, but also retaining and making sure that this data set stays perfectly level. So now I'm ready to go tying this project or this data set into the primary control. So just like other times, you always want to leave the bundle locked since you know that this registration is tight and accurate, and I don't want it to change. So now, sitemap, let's go tie in, find a setup that has common overlap. So I know that these two are close, have some overlap. So now, just like normal, finding a common corner, rotating, on finding common overlap. Nothing different than like normal. Okay. For this example, I'm just going to do the one setup, but best practice is always when you have multiple setups from control tied into multiple setups from your current data set. So now that I have everything tied together, I also have the primary control coordinate system. So now as I come into this data set and I come in, turn off these setups, I can now see that these control points that we shot in before to get our elevations now have an XY, a correct northing easting that we're going to go and utilize for our control file. So if you wanted, you can also kind of see from this benchmark back to the original starting point. So originally our control point 1 was 101.586, or is a positive 1.586. Now because of the control scan and just due to the nature of how far away we are, the X, or the delta Z, excuse me, has changed a little bit more than our 1.586. This is a pretty extreme example just to make it obvious, but that's why you want to do this kind of workflow for these kind of scenarios. So then my second one, 1.105. So 1.105, now we're we were 1.033. So about 3/4 inch of shift or elevation change that adjusted. So just to really make it obvious and see what's happening. But so now all we got to do, oops, I want to leave all that off still, is we just need to come in and record our XY values for each of these control points. So let's come in, use my pick points. Now we're going to come in and create our text files. So 1,744,825,0.606, 153,600.268, and I have my corrected elevation already input. .237. 3. And last one is 744,813 0.729 153,577.213. Okay, so now here is utilizing the X and Y for the transform to get it right in the plan view, and then we're going to go use our elevations from before to make sure it stays level and is set perfectly to the elevation we want based off that one known control point. Save as, I'll just save the desktop for now. Well, yeah, I'll just throw it in a different folder. Alright, back to our import. Bring in our corrected control. So now we have our 3 points, all with the correct Z elevations off our 100 benchmark. So now we're just going to come into, not sure why I brought that in as a setup, interesting. Come in, go lock everything, want to make sure I turn off, don't need that. Get rid of that setup it brought in for some reason. But so now we have no control applied, just like before. Your measurements are arbitrarily out in space, so now nothing different. Come in and apply control. So now we have those 3 control points that we brought in, and we can see that it basically came in perfectly. Elevation is really the key thing, making sure that all stays the same, but all of this is 0 across the board. So now as we come in and check, make sure that our elevation deltas are all the same. Actually, turn off my control So now, just like before, 1.584, 1.586, 0.02 of a foot, which is absolutely nothing. So all of this is coming in correctly. 1.033, yep, exact same to our last one, 1.338. Oops. Yeah, 100 minus 98.662. Yeah, off 1,000th of a foot. So once again, nothing wrong, nothing different. So that's the correct way to kind of make sure that your data set stays perfectly level. And after you have all that done, then you can just come in like normal. Oops, get rid of my measurement, that's why. Then you can just come in, delete your control scans, get rid of them, and export out just this bundle with the coordinates applied that you need for export. So that's the kind of correct way to go do that. Hopefully this works, and it can be used as a reference. If you have any issues, just always feel free to reach out with anything you got.